Hello everyone, welcome to Career Launcher, and we are back with the Snap 2025 Analytical Reasoning Data Interpretation. We have already done one session on data interpretation previously, and this is the second session of data interpretation, and where we are going to discuss few more questions of Snap. That what kind of questions we can get. Generally, questions of data interpretation are easier in Snap. You can solve one question in less than a minute, and that kind of exam it is. Just what do you need? You need to have the basic calculation skills as well as the comprehension skills of any data. That's it. So most of the questions that Snap has asked are very straightforward. So now let's see. So basically, what does this question says? The following diagram shows that failure rate of four different electronic components of a device. So this is what that is given. Okay, so failure rate of component device. Now, before reading any data, so basically it says number per thousand, and it is the name of the devices, right? So basically, these two things are given. What are the numbers? I don't care. I'm directly going to read the question and figure out whether I can calculate the answer or not. Okay. For which of the following components has a failure rate of 25% more than that of signal devices? So what is signal device? That is this. What is the failure rate? That is going to be 16. Okay. 25% of 16 is going to be what? 4. So we are looking for a component that has failure rate of 25% more than signal devices. That is going to be 20. So which device has 20%? Which device has failure rate of 20? That is capacitors. So answer of this question is directly going to be option B. That is going to be capacitors. Now, the next one, what does it say? The table given below shows the annual income of Aman and his savings as a percentage of income. Okay, so these two things are given to us. Now it says that year is given, the saving percent is given, so all those things are given to us. Now the question is talking about which of the following years was the saving of Aman was second highest. Okay, now the question is not talking about highest, question is talking about second highest. So 10% of 5, that is going to be 0.5. Okay. 12% of 5, so 12% of 5.5, that is going to be 12 fives are what? 6, 12 fives are what? 6. It is going to be 0.66. Okay. 13% of 6 is going to be 0.78. So basically, this cannot be the second highest. Oh, rejected. This is highest, the second highest. Okay. So 2011, okay, that was not even in the option. So no need to consider. Now 11 8s are 88. Okay. 11 6 are 66. 66 plus 8 is going to be 74. Okay. Now this can't be second highest. Okay. So rejected. 2012 is gone. 9 7s are 63. 9 7s are 63 plus 6, 69. So that is going to be 0.693. Highest, second highest, third highest. So second highest is going to be in 2014, and that's going to be option C. So it was simply a calculation intensive question. Just look at the data, calculate it, and get the answer. The highest one I can guess, but for second highest, I think I need to make a lot of guesses. I don't want to do that. So that's the reason I'm simply calculating all the values so that I don't get it wrong. Now, the next one, what does it says? The adjoining diagram is frequency polygon for the weights of the students in class. What is the total number of students in the class? Okay. So just read the question, think, then I'm going to explain what is it. So if you simply just look at the data, horizontal line is talking about weight, vertical line is talking about number of students. So basically it says 35 students got a weight, 20 students have a weight of 35. 30 students got a weight of 40. 55 students got a weight of 45. 30 students got a weight of 50. That's what it says. So basically 20 students are here at 35. 30 students are here. So if I'm looking for total number of students in the class, I'm just going to add up all the numbers. 20 plus 30, 50. 50 plus 30 is going to be 80. 80 plus 20 is going to be 100. So I got 100 from this. Now this is going to be 55. This is going to be 35. So 55 plus 35 is going to be 90. Okay. 90 plus 45 plus 25. So 45 plus 25 is going to be 70. So I'm going to get 100 plus 90 plus 70, and that comes out to be 260. That's going to be efficiency. Now let's look at the next question. What does it say? Now just read the data, understand, and let's see. There are players. The runs scored in the first inning, balls faced in first inning, runs scored in second inning, balls faced in second inning, and question is talking about the fastest run scorer in the test match. Okay. So fastest run scorer means the runs scored in lesser number of balls is going to be the fastest run scorer. Okay. So all of us know that in test match you are going to have total of 2 innings. So if I talk about player A, what is the total number of runs he is scoring? 61 plus 14, that is 75. How many balls he is playing? That is 99 plus 76, that I can say 175 balls. So run rate is less than 0.5. 5 plus 50, 55 runs. In how many balls? That is going to be 97 balls. Okay, so by looking at this, I can definitely say this guy is better than this guy. Run rate is, this guy is scoring more runs at a faster rate than this guy. So A cannot be the answer. Now if I'm going to look at this guy is scoring how much? 35. How many balls this guy is taking? 125. Not fastest, not at all. Next guy is scoring 25 runs, 13 plus 12. In how many balls? 105. Can he be the fastest? Definitely not. So answer of this question is directly going to be option B. Just write it like this and you are going to get the answer. Very quickly, you don't need to do any calculation. If you are going to write it like this, it becomes clearly evident that who's the fastest guy. That has to be B. This one. Now, the bar graph given below shows the age-wise percentage breakup of buyers of an item during the period 95 to 99. Okay. It is given that number of buyers. Okay. So basically, number of buyers are same in every year. So I'm going to assume number of buyers are always 100. Okay. So 10 to 20 is 30 if I'm talking about year 1995. So year 1995, I had a total of 100 buyers. Out of that, 30 has an age of 10 to 20, 60 has an age of 20 to 40, and 40 plus years are 10. Okay, this is what data is saying. Now I'm going to read the question. By what percent did the number of buyers in the age group decline from 95 to 99? Okay. In 95, what is the number of people? That is 60. In age group of 20 to 40. In 99, how much it is? That is 16. So I am going from 60 to 16. So how much a decrement we are talking about? We are talking about a decrement of 44 over what? Over 60 into 100. So this value is definitely greater than 26%, definitely greater than 44%, definitely greater than 20%. So answer is directly going to be option B. That is going to be 73.33%. So answer of this question directly comes out to be 73.33%. Should we calculate a lot in this question? No, because options are such a way. If you look at the change, the initial value was 60, final value is less than 30. So there is an overall decrement of more than 50%. That is clearly evident by the data. So just pick any option that's greater than 50. There is only one option. Now, if there are multiple options, in that case, I would have need to solve that question. Otherwise, I don't. Let's see this one. Now the question is saying, the following graph shows the expenditure incurred by a family on power consumption and internet usage for the past 6 months. Okay. Now I need to calculate. There are two graphs, two line graphs are given to us, and I need to calculate the average. How would I do that? Now, in these kind of questions, the general issue is any value is not given, just dots are given. And you need to do some guesswork so that you don't get your answer wrong. So that's why options are created in such a way so that even if you approximate a little bit, you don't get the answer wrong. So this is how options are created. Remember this. This is an important part. That if you see, first option is 856, then 872, then 974, then 908. So options are created in such a way so that you don't get confused and get the wrong answer. No, you can easily calculate the answer. Now, what I'm doing, I am saying I am taking this as a baseline. Average of this and this, these two numbers, is definitely greater than 900. Definitely greater than 900. Average of this and this is going to be little less than 900. Little less than. And this is very greater than 900. Okay, so little less than, so let's say 890ish or something. Fine, 890, 895ish type. Okay, if I look at this data, this and this, average is going to be close to 900. Now this value is far greater than 900. This value is 895ish. This average is 900. So overall average comes out to be close to 900 itself. 900, 905, 910. So, but definitely it can't be 974. So basically, option C cannot be my answer. And I know it is going to be very close and little greater than 900. How many options do we have in that case? Only one option, that is option D. So this is how I can directly pick the data even if values are not given. Because remember, options are created in such a way so that even with a little approximation, you still end up at the right answer. I hope everyone understood. Now, this one. The line graph given below shows the ratio of wheat production to rice production in a state in India in the period of 2008 to 2014. Okay. So it is saying that wheat to rice. This ratio is given to us. This is 0.6 in 2008, 0.7 in 2009. This is 0.456 in 2010, and that is given to us. Okay. The rice production in 2012 was 4 lakhs. Okay. In 2012, this value was 1.2. Okay. And I am asked what is the wheat production, so that is 4. So wheat production I can directly calculate, that is going to be 4.8. Very easy question, very easy question. So answer of this question is going to be option C, that is 4.8. Nothing much to do. Straightforward question. Now look at this. The line graph given below shows the revenue and expenditure of a company during the given period 2008 to 2012. For the years shown, the largest difference in the revenue and expenditure occurred in which year? Okay. The largest difference between revenue and expenditure. If I look at this particular question, if I see, can it be highest difference? This is revenue, this is expenditure. Is it that? Can it be highest? No. Can it be highest? No. Can it be the highest? Maybe. Can it be highest? Maybe. Can it be highest? Maybe. I'm just rounding off. 7,000 minus 1,000, that is going to be 6,000. This difference is close to 6,000. 10,000, or I would say 11,000 minus 4,500, that is going to be what? 6,500. Okay. 12,000 minus 5,000, that is going to be what? 7,800. Sorry, 7,000. So where I can get the largest difference, largest possible difference, that is going to be option D. That is clearly visible. Should we calculate for this? I would say no. Just look at the data, get the answer, and in that way you can easily get the answers. Just look carefully. This one. The adjoining diagram of a frequency polygon for the runs scored by Sachin against different teams. What is the total number of runs scored by Sachin? So against country A, how much Sachin scored? That's 1,000. Against country B, how much did he score? 600. So 1,600. Against country C, he scored 800. Okay. Now it is already 12, 2,400. Okay. So basically, this option is not possible. This is also not a possible answer. Now this is against this country, against D, it is 400. So I got 2,800. Against this, I'm also going to get 1,200, 600 plus 600. So overall, it comes out to be 4,000, and that's going to be option D. So this is how you should tackle the questions that come in SNAP. Just read slowly, and by the time you finish reading, you should have your answer, because generally questions are based on data. Just look at the data and get the answer. So these kind of questions we see. Now, if anyone has any doubt, you can definitely ask your doubts. I'll take care of your doubts. Anyone has any doubt regarding anything? So, no doubt so far. Okay, with this, let's conclude. Take care. Bye bye.